In this video, we're going to have an introduction to graphing. With this introduction to graphing, we're going to introduce a set of vocabulary so that you can become familiar with the Cartesian coordinate system. So our quadrants are found once you identify the x and y axes. The x-axis is a horizontal line, and it includes negative values and positive values. The y-axis is our vertical line, and it also includes positive values above the x-axis and negative values below. So you can now see that we have 4 different spaces or quadrants that we are labeling. With Roman numerals, we've got quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So in that first quadrant, you can see that the x values and the y values are positive. In the second quadrant, x values are negative and y values positive. In our third quadrant, both the x values and the y values are negative. In our fourth quadrant, x values are positive and y values are negative. Where the x and the y-axis meet, right here, is called the origin. So the origin is a very important location on the Cartesian coordinate system because that's pretty much our home base. We're always going to start there. And if we are given an ordered pair with x and y values, we move in the direction of x first and then in the direction of y. So you can see that 3, 5 is a point given to us. So the way we get to that ordered pair is go 3 units positive for x and then 5 units positive for y. And that location is the ordered pair 3, 5. Now we have an opportunity to practice plotting some ordered pairs. Notice the x-axis is already labeled and the y-axis. So if we are given the first ordered pair of 3, 6, that means we're looking for x value of 3 and y value of 6. So we begin at the origin, that's 0, 0. Move 3 units positive for x and then 6 units positive for y. There's our dot, 3, 6. The next ordered pair is 2, negative 1. So I move 2 units to the right for x and down 1 unit. So 2, negative 1. Negative 4, negative 1 means I'm starting at the origin, moving 4 units to the left, 1 unit down. Negative 3, 4, I go negative 3 units for x, but positive 4 for the y. 5, 0. Be careful here, starting at the origin. 5 is in the x value place. So go 5 units positive for x. And if y is 0, we don't move anywhere else. We're sitting right there on the x-axis. That is 5, 0. And the last one, 0, 3. So x is worth 0, y is 3. Starting at the origin, do not move anywhere for x, so stay right at 0, but then move 3 units positive for y. 0, 3. Typically, any ordered pair with a 0 involved tends to be the more difficult one to locate, so you might want to double check any time a 0 is involved. And finally, we are already given some ordered pairs on the Cartesian coordinate system, and we need to write down the values of these points. So finding point A, here's A, so it looks like for x, we're not moving anywhere to the left or right. So I'm going to have a 0, but then I'm going to move down 1, 2, 3, 4 units. So that would be negative 4. 0, negative 4 is point A. Point B. X is our first direction, so 1, 2, 3, 4 to the left, 1, 2, 3, 4 down. So x value negative 4 and y value is also negative 4. For point C, we're moving 1, 2, 3, 4, 5 to the right, but then nowhere up or down. So that would be 5, 0. Point D, 1, 2, 3, 4 positive, 1, 2, 3, 4 positive. That would be 4, 4. Point E, I'm going 2 units to the right, 1 unit down. So 2 units for X, down 1 for Y. And finally, our last point, looks like we need to go left. So 1, 2, 3, 4 units left, 1, 2, 3, 4 units up. So negative 4 for the X value, positive 4 for the Y value. And the last thing we're going to do with our introduction for graphing is to determine whether these ordered pairs are solutions to this given linear equation. So remember, ordered pairs are X value first, Y value second. So what we actually have is 3 separate ordered pairs, and all we have to do is substitute these X and Y values into the given equation and see if they work. So in the first case, we'll have 3 times X value of 0 minus Y value of negative 12. And we want to determine if that really equals 12 or not. So notice with subtraction of Y, I have subtraction and parenthesis. That's because sometimes we're going to have a negative Y value, and I don't want to forget to include that negative with the Y value. So 3 times 0 is 0. Subtraction of a negative means add 12 equals 12. So it looks like 12 is equal to 12. That's true. So we have, yes, 0, negative 12 is a solution to that linear equation. Let's try the next ordered pair. 3 times X value of 1 minus Y value of 9. Does that equal 12? 3 times 1 is 3. Subtraction of 9 equals 12. Well, here on the left, 3 minus 9 would be negative 6. And that does not equal 12. So we know that the point 1, 9 is not a solution to the linear equation given. So that point would not be on the line. Our final check, 3 times 2 minus the Y value of negative 6 equals 12. 3 times 2 would be 6. Subtraction of a negative becomes plus 6 equals 12. 6 plus 6 is 12, and 12 does equal 12. So we also know that the ordered pair 2, negative 6 is a solution. So the first and the last points are solutions. The one in the middle doesn't work. So that's how you can check to see if an ordered pair is a solution to a linear equation or not.